Hi students, in this video we are going to continue our series of 99 percentile, and the chapter we are going to discuss is permutations and combinations. So many students, what they do, whenever they see a permutations and combination question, they just leave the question without even attempting the question. Okay, but the thing is, when it comes to mains, for the last few years I have analyzed all the questions, and the permutations and combination questions were dead easy. Okay, if you are skipping permutations and combination questions, that is a pure mistake you have to do. So don't skip the question. So just go through the question, read the question, understand the question. If you are getting the idea, then just solve it. If you are not getting the idea, then you leave it with, but don't leave the question without reading the question. I can prove in this video also that most of the questions were easy, right? And you can get most of the questions in 3 or 4 steps also. So just let's dive into the question paper and let's start the first question here. So what's the first question given? Here the largest n belongs to natural numbers for which 7 power n divides 101 factorial. So it's a pretty straight question. So here it comes to the concept of exponent of a prime number p in n factorial. The formula for this is exponent of a prime number for n factorial is box of n by p, where box means greatest integer function, by box of n by p square plus box of n by p cube plus and so on, right? Eventually at some point it is going to be 0, then after everything else will be 0, right? This series will be there. So now if you are applying this formula for this question, so exponent of 7 in 101 factorial, right? So how to solve? 101 by 7 box plus box of 101 by 7 square plus box of 101 by 7 cube. 7 cube already we know 343 and so on, right? So here 101 by 7 means so this is 1 time 31 means 14 point something. So box of 14 point something is 14 plus, so 101 by 7 square means 49 means 2 point something, so box value is 2, then you will get 0. From here onwards you will get zeros. So the exponent of 7 in 101 factorial is 16. So 101 factorial can be written as 7 power 16 into some k, where k is an integer, right? So the maximum of power of 7 is 16 here. So that's what they are asking for. So the largest n belongs to n, for which 7 power n divides means it has to be 16. It's pretty much easy question, right? So let's go for the second question. So what is given? So read the question here. The number of 4-letter words you need to form without meaning, which can be formed using the letters of the word. So here one letter is given, right? So what is PQR, PQRS, TU, VP, right? So very straight question. What is given here? So we need to form 4-letter word, right? So it has to be formed from this letters of this word. What is that letter? PQR, PQRS, TUVP, right? So in this word, how many P's are there? 1, 2, 3. 3 P's. How many Q's? 1, 2, right? How many R's? 1, 2. Remaining S, T, U, V. So S, T, U, V are single letters, right? One time, right? Now using these letters we need to form a 4-letter word. So now you in what perspective you have to think is, so you can think of that 4-letter word can contain all distinct letters, one possibility, or 2 of the letters can be repeated, or 3 of the letters can be repeated, or 2 of the letters repeated twice, right? So what can I say is, case 1 I can say all 4 letters are different, all 4 are different. Okay, so how many different letters are there for us? PQR, these are 3, and S2, UV 4. Total 7 different letters are there. Okay, so if all 4 must be different, I need to select 4 from this 7. So which is 7C4. Now what I have 4 letters, right? So now in how many ways I can arrange the 4 letters? 4 factorial, because all are distinct only. So 7C4 into 4 factorial. So this is the first case. So we can calculate, which is 7C4 means 7C3 into 4 factorial, that is 7 into 567 by 6 into 24, 35 into 24, that means 70 into 12, 12 sevens are 84, 840 words can be formed with all letters are different, right? Case 2 is 2 are repeated, exactly 2 letters, exactly 2 are repeated, right? So we can do this case. So exactly 2 are repeated means, yeah, so those 2 letters I can select from P, either P or Q or R. So how many possibilities I can select? So out of these 3 letters I can select one of the letter, right? So now I can take 2 of those letters, and now I needed 2 more letters which have to be different. So suppose if I selected Q and I have selected all the Q's, now I have 1, 2 and so on, 6 different letters. Now from those 6 different letters I need to select 2. So finally I have 4 letters, out of which 2 are repeated. In how many ways I can arrange them to form a word? 4 factorial by 2 factorial. Done? Right. So let's calculate how much it is. 3 into 62 means 6 into 5 by 2. 4 factorial means 24 by 2, which is 12. So here you are getting 3. 45 times 12. So that means 96. So which is 540. So here 540 words, here 840 words. Next, case 3. So what is case 3? Two letters are repeated. 2 letters are repeated twice. That means, so you need to select 2 letters which will be repeated twice. So that means out of these P, Q, R, I can select any 2 of them, right? 3C2, I have selected any 2 of them. Now I have 2 letters each, right? So in how many ways I can arrange them? 4 factorial by 2 factorial, 2 factorial. So what this value will be? 3C2 means 3C1 only, so which is 3. So 24 by 4 you will be having 6, so which is 6 3s are 18. So 18 words will be formed. Now last case, case 4, 3 letters are repeated, right? So 3 letters are repeated. That means I have to choose from P only. So I have to take 3 P's. In how many ways I can take? 1 way only. Now I need to select one more different letter. So how many different letters are left? So 6 different letters are left. So out of those 6 different letters I will choose one. Now I have total 4, out of which 3 are repeated. Now I can arrange them in 4 factorial by 3 factorial. Simple. So here 4 factorial by 3 factorial means 4. So you will be getting 6 4s are 24 words. Now case 5 is not possible because 4 letters can't be same, because here only maximum is 3 letters only repeated, right? So the total is 840 plus 540. How much, right? 80 and 1380 plus 18 plus 24 plus 18 means that is 12, 42. So if you add them, 42 to 12, 1422. So the answer must be 1422. So it's just a simple case of counting, so you can solve it easily, right? Next, question number 3. So let's go for third question now. So read the question first of all. 3 persons enters in a lift at the ground floor. Okay, 3 persons are entering the lift at the ground floor. The lift will go up to 10th floor, right? The number of ways in which the 3 persons can exit the lift at 3 different floors. Okay, everyone should exit the lift at different floors. If the lift does not stop at first, second and third floors, is equals to, very simple question this is. So thing is, there are 3 people and 10 floors. The lift does not stop at first floor, second floor, third floor. So there are remaining 7 floors, right? 7 floors. Now out of these 7 floors, 3 members has to exit the lift at different floors, right? At different floor means out of these 7 we need to select 3 floors, right? Now I have 3 floors and 3 persons are there. Now these 3 persons can go to any 3 of the floors. So in how many ways they can arrange? 3 factorial ways. That's it. So this should be the answer. So in how many ways it will be done? 7c3 into 3 factorial. So which is 7c3 means 7, 6, 5 by 6 into 6. So how much? 7, 6 are 42, 42 into 5, 210. So 210 ways. Done. So very simple, just 2 steps of the answer, right? So that's why you don't skip PNC question. Okay, it can give you in 2 or 3 steps, right? Yeah. So next, the same similar question we have done in the first question, right? The largest value of n for which 40 power n divides 60 factorial, but our formula works for prime number, right? So but here 40 is not a prime number, but still we can do. So what we can do here, 40 we can write as 8 into 5, so which is 2 cube into 5. So what I will do is I will evaluate the exponent of 2 and I will evaluate the exponent of 5 in 60 factorial, right? So exponent of 5 in 60 factorial is 60 by 5 box plus 60 by 5 square plus 60 by 5 cube plus and so on, right? 65 by 5, 60 by 5 means 12, 60 by 25 means 2 point something, so 2, then 0 you will get. So exponent of 5 is 14. So exponent of 2 in 60 factorial. What we can do? So 60 by 2 plus 60 by 2 square plus 60 by 2 cube plus 60 by 2 power 4 plus 60 by 2 power 5 plus 60 by 2 power 6 plus and so on. So how much you will get? 30 plus 15 plus 7 plus 3 plus 1 plus 0 and so on. So how much you are getting? 30 plus this is 40 plus 15, 55, 56. So exponent of 2 is 56. So that means, so 60 factorial can be expressed as 2 power 56, right? 2 power 56 into 5 power 14 into some k. K can be an integer, right? So now you need to express as 40. That means 2 cube into 5. So what I can write is 5 power 14. 2 cube power 14 means how much? It is 1242, right? Yeah. So I can separate 42 means 2 power 14 I will separate, right? So 2 cube whole power 14 into 5 power 14 into k. That means 2 power 14 into 40 power 14 into k. So the maximum power 40 can take is 14. So the answer must be 14. Done? Yes. Third option. So it is also an easy question, right? So let's go for fifth question. So the letters of the word Udaipur are written in all possible ways with or without meaning, and these words are arranged in a dictionary order. The rank of Udaipur word is. So it's a pretty board exam question. So we can solve the question very easily. So we need to calculate rank of Udaipur, right? So what is Udaipur? Udaipur. Okay. Now, so arrange the letters in alphabet order. So which is A, D, then P, R, U, W. I mean there are 2 U's and Y, right? So how many letters are there? 3, 6, 7. 7 letters are there. Done. Yep. So now how to calculate the rank? So let's calculate the number of letters that starts with A. So 1 A, right, and remaining are 6, 1, 2, 3, 6, and out of those 6 I have 2 U's. I can arrange them in 6 factorial by 3 factorial, sorry, 6 factorial by 2 factorial. So these are the number of words that starts with A, right? Next, after A, let's go for D. So what I can say? So same thing. So with D also, the number of words it can form is 6 factorial by 2 factorial. The same thing happens with the P also, same thing. With R also the same thing, 6 factorial by 2 factorial, right? Now it starts with U, right? Once U comes up, so once U comes up, right, U will be fixed because the first letter of Udaipur is U. Now we have A here, so let's start with A. Then how many letters are words can be formed? So after U and A, we have these letters in which there is no repetition. So there are 5 letters and that can form 5 factorial words, right? Then after A, it comes up with D. So already U gone, U is fixed, then D is also fixed, right? Now again I will start with A. So A is also fixed because Udaipur, right? So you are left out with 4 letters now. Now out of these 4 letters, so A is gone, D is gone, and U is gone. Now we start with P. Okay, so P means if you fix P here, you are left out with 3 more letters, and they can be arranged in 3 factorial. Again, you can start with, after P, you can start with R. Again you will be having 3 factorial. Then again you will start with U. Again you will be having 3 factorial. After U we have our Y. So now Y will be fixed. After that Y is fixed already. Next, after that we have P. We can have PRU, that is 1 letter, or PUR, that is the last letter, and that last letter is Udaipur. So now you need to calculate the total number of words formed. So how much here? 6 factorial by 2 factorial occurred 4 times. So our rank will be, here I am writing 6 factorial by 2 factorial 4 times occurred, plus 5 factorial plus 3 factorial has occurred 3 times, 3 into 3 factorial plus 2, right? So now 6 factorial means 720 by 2, 360 into 4. So you got 0, 24, 12, 1440. 1440. 5 factorial means 120. 3 factorial means 6. 6 3s are 18 plus 2, 20. So you are going to have 0, 8, 1580. So 1580 must be the rank of the word Udaipur. So this is also pretty easy question, board question, right? We can solve the question. So 1580 is the answer. Let's dive into the 6th question now. So now what is the question they had given? Let ABC be a triangle. Consider 4 points P1, P2, P3, P4 on side AB, 5 points on side BC, 4 points on side AC. Okay, so let's draw a rough graph. So ABC is a triangle, so they were saying ABC. Okay, so they are taking 4 points on AB, P1, P2, P3, P4, and 5 points on BC, P5, P6, P7, P8, P9, right? So 5 points on BC and 4 points on this one, AC, P10, P11, P12, P30. Done. Now none of these points is a vertex of triangle ABC, so they are not coinciding with the vertexes. Then total number of pentagons that can be formed by taking all the vertices from P1, P2 and so on P30, right? It is also pretty easy question, but just you need to read the question carefully, plot a rough sketch so that you can understand the question properly. So here, coming to the question, we need to form a pentagon. Yeah, right? Yeah, pentagon means how many vertices should be there? 5 vertices. 5 vertices. Now, so to form a pentagon, the 5 vertices 5 vertices means 5 sides should be there. So what we can do is, I can select one side from here, and 5 vertices we have to select. So what I can do is, I can select any 2 vertices from here, any 2 vertices from here, and 1 vertex from here. So if I select like this, I will have a pentagon like this, right? I can again do the same thing, like 2 vertices from here, 2 vertices from here, 1 vertex from here. That's it. Again you will have pentagon. So you have to repeat the process. So the answer is pretty much simple. So first of all, in how many ways we can form a pentagon means, so from AB I can select any 2 vertices. AB has 4 vertices, 4C2 into, from BC I can select 2 vertices, 5C2, and AC also having 4 points, I can select any one of the vertex. Now the pentagons are formed. Plus other possibility is I can select any 2 from BC, so which is 5C2, and any 2 from AC, which is 4C2, and any one from AB, so which is 4C1. This is also other possibility. Plus another possibility is I can select any 2 from AC, which is 4C2. I can select any 2 from AB, which is 4C2, and I can select any one from BC, which is 5C1. So in these many ways pentagons will be formed. So how many pentagons formed? 4C2, 5C2 means 4C2, just to evaluate the values, 4C2 means 4 into 3 by 2, 6, right? 5C2 means 5 into 4 by 2, which is 10, right? Just substitute the values. So 6 into 10 into, sorry, 6 into 10, 60 into 4, 240, plus 10 into 6 into 4, plus 6 into 6 into 5. So this is 240, this is 240, 480, plus how much is this? 36 5s, 30, 180. So how much? 0, 6, 660. So how many pentagons can be formed? 660 pentagons. Simple. Done. So we are done with that question. Now let's move to the question number 7. So the number of ways in which 16 oranges can be distributed to 4 children such that each child gets at least 1 orange. It's a pretty direct question. So that means there are 4 children. We need to give 16 oranges. Okay, and each child should get at least 1 orange. Let us say x1 be the number of oranges child 1 gets, x2 be the number of oranges child 2 gets, x3 is the number of oranges child 3, and x4 is number of oranges for child 4. The total number of oranges must be equals to 60. Now each x1, x2, x3, x4 must be greater than or equals to 1. That means total number of positive integral solutions, right? Total number of positive integral solutions for this equation. Now what is the formula for total number of positive integral solutions? N minus 1 C R minus 1, which is N is 16, so that is 15 C, R is 4, 15 C3. Very simple, directly one step answer. So 15 C3 means 15 into 14 into 13 by 6. 3 table 5 times 2, 7. So 35 into 13. How much? 15, 105, 3, 5, 455. So we are going to get 455. So the first option is the answer. Done. So let's move to the question number 8. What we have here? Let S denote 4-digit numbers A, B, C, D such that A greater than B greater than C greater than D. Let P denote set of 5-digit numbers having product of its digit equals to 20. Then N of S plus N of P you need to calculate. Okay. So try to understand the question clearly, then we can directly solve the question. So S says that the set of 4-digit numbers A, B, C, D you need to calculate such that A greater than B greater than C greater than D. Okay. So simple. So we need to form a 4-digit number and it should follow this inequality, right? So whatever the any digit number can be formed using the digits 0, 1, 2, 3, 4 and so on up to 9. How many digits are available? 10 digits including 0, right? Now what I will do is we need to form a 4-digit number, and this inequality should happen that indicates that all the 4 digits must be distinct, right? Otherwise if they are not distinct, equality will happen, no? So for strictly greater than or whatever the relation, it should be distinct. So that means out of these 10 digits I need to select any 4 of the digits. So what I will do is I'm selecting 4 digits of those 10 digits, right? Now I have 4 digits, 4 distinct digits. Now in how many ways I can arrange them to form the number? One way. Why? Because if I have any 4 digits, let us say 0, 2, 5, 7, 9, 0, 2, 5, 7, so they will be arranged automatically as 7, 5, 2, 0. And you don't need to bother about 0 also, because 0 is going to be at the last, because it is the least of any number, right? So in how many ways they can be arranged? One way only. So this is the number of ways in which the number can be formed. So which is 10C4. 10C4 means how much? 10 into 9 into 8 into 7 by 4 factorial, which is 24. 8 times 3, 3 times, so it is 210. So number of elements in S is n of S is 210. This is done. Now second part, what is the other part they are asking for? P denotes set of 5 digit numbers having product of its digits is equals to 20. So P is a set of 5 digit number, product of digits is 20. So for the product of digits to be 20, what I can say is I can write 20 as 4 into 5, or I can write 20 as 2 into 2 into 5, right? So now from this what I can say is, so I can select 1 4, 1 5 and everything else can be 1, right? So I need 5 digits, right? And their product has to be 20. So if I select 4 and 5, the rest should be 1s, right? Otherwise, if I can select 2 2s, 1 5 and the rest can be 1 only, right? So these are the possible options for us. Now once we selected the letters, in how many ways we can select the digits? One way only, right? Now in how many ways they can be arranged? So as there are 5 digits, 5 out of them 3 are repeated, so 5 factorial by 3 factorial. And in how many ways these can be arranged? 5 factorial by 2 factorial into 2 factorial. 5 factorial means 120 by 6, you are going to get 20. 5 factorial means 120 by 4, you are going to get 30. So total is 50. So now this is n of p. So n of p is 50. So what they are asking for? N of s plus n of 50 to n of p. 210 plus 50. How much? 260. So it is also simple question. See. So this is why you need to understand the PNC question, then solve the question, right? Next, question number 9. What is given here? So let's read the question. The number of strictly increasing functions from the set 1 to 5 6 and to the set 1 to 9 such that f of I not equals to I for 1 less than or equals to I less than or equals to 6. So this is also a repeated PYQ question. These kind of questions earlier asked in 2024-2025, right? So just for understanding, I am plotting this one. Sorry. Right. So let us say there is set here. So there is a set A, there is a set B. Set A is containing 1 2 3 4 5 6. Set B is containing 1 2 3 4 5 6 7 8 9. Okay, done. Now we needed to form increasing functions, right? Strictly increasing functions. Okay, so first try to understand what the question is asking for. So strictly increasing functions means, suppose if I mark 1 with, let us say 1, now I should mark 2 with more than 1, because if we go from 1 to 2, the functional values must be increased, right? So if I want to match 2, I need to match 2 with more than 1, which is I can match with 2, right? And then again 3 I should match with more than these 2, like that. But here few more conditions are also added, so which are like f of I should not be equals to I. So that means 1 cannot be mapped with 1, right? So that means 1 should be mapped at least with 2. Let us say I can map 1 with 2. Okay, so let us consider I am taking this case. Okay, now I need to construct a strictly increasing function Now if I want to map 2, I need to map with at least 3, right? And I can map 3 with at least 4. So what I can do is I can divide them into cases. Now the case 1 is mapped with 2. Okay, so I'm mapping 1 with 2. Now here I am left out with 5 different numbers, right? And here other numbers I can map the numbers with is starts from 3 to goes to 9. How many numbers are there? 7 numbers are there. Now what I can do is, out of these 7 I can select any 5 and I can map those 5 elements with this 2, 3, 4, 5, 6 in one way. How? Because if I select 3, let us say 3, 5, 7, 8, 9, I have selected these 5 letters. Now I should definitely map 2 with 3. I should definitely map with 3 with 5 because it should be increasing order, right? So that's it is the same question as this one. Which one? Yeah, this part. Okay, so because they are in increasing order, we can arrange them in one way. So that means when I mapped 1 with 2, the rest of the 5 can be mapped with these 7 in 7C5 ways. So in this case I am going to get 7C5, so which is 7C2. So you are going to get 7 into 6 by 2, which is 21. Now another case is also possible, which is I can map, so I am erasing this, sorry, I can map 1 with 3. Okay, I am mapping 1 with 3. Now in this case I am left out with 6 options, in which if I select any 5 I can get let us say I can arrange them in one way again. So I am getting 6C5 ways. And another case what I can do is I can map 1 with 4, right? I am left out with 5 letters and I can select any 5, that means 5C5 ways. So I can arrange them in 5C5 ways. So another case is 5C5 ways. Now suppose if I map 1 with 5, I am left out with 4 numbers only. So 4 numbers, but we have to map 5 more numbers and it has to be more than 5 only. So is it possible? No. So in this case it is not possible. So only 3 cases are possible and the answer will be 7C5 plus 6C5 plus 5C5. And we can use binomial property here, KCK plus K plus 1 CK plus that one will be N plus 1 C K plus 1, which is 8C6. I can write 8C6 as 8C2, that is 8 into 7 by 2, which is 28. So total 28 strictly increasing functions can be formed. So the formula I used here is, I am writing here, KCK plus K plus 1 CK plus K plus 2 CK plus and so on, NCK is N plus 1 CK plus 1. So memorize this formula, right? So anyways, let's go to the next question, 10th question. So what is given here? S is one set, M comma N are there. M comma N belongs to 1 to 50 if the number of elements M comma N in S such that 6 power M plus 9 power N is a multiple of 5 is P. Okay, so let's see this first part. So this the first part is P. The number of elements M comma N in S such that M plus N is a square of the prime number is Q. Then you need to calculate P plus Q. So of course you need to calculate P and Q, right? So coming for the first part, you need to select the numbers from 1, 2, 3 and so on up to 50, right? Now here 6 power M plus 9 power N must be a 5 multiple. That means it should be a 5k form, right? So whenever these kind of questions are there, when we have to check here 5 multiple, try to check the nearest 5 multiple for the base. So that means here 6 is there, the nearest 5 multiple is 5, right? So 6 I can write 5 plus 1 whole power M, and 9 the nearest 5 multiple is 10. I can write 9 as 10 minus 1 whole power M. Now we can take the help of binomial expansion and we can expand it. So I will be getting 5 power m plus mc1 into 5 power m minus 1 plus and so on. Up to last but one term I can have 5 and the last term is 1 power m, so which is 1. So this is the first expansion. The next expansion is 10 power n minus nc1 into 10 power n minus 1 and so on, plus ncn minus 1 into minus 10 power n minus 1, sorry 10 power 1 minus 1 whole power n minus 1 plus minus 1 whole power n, right? This is the expansion. Now here up to last but one term you have 5, so can I say that is of the form 5k plus 1, and up to last term every term is having 10, so can I say if I take 10 common, that will be of the form 10k2 plus minus 1 whole power n. So here this one if you this is also 5 multiple plus 5 multiple is 5 multiple, 5k plus 1 plus minus 1 whole power n. So finally for this format to be a 5 multiple, obviously this n must be odd. If n becomes odd, it will become minus 1 and this minus 1 will cancel out and it will turn up to be 5 multiple, right? So now the condition for this number to be 5 multiple is n must be odd, right? So n belongs to odd, very simple, n belongs to odd. So in how many order pairs we can form? So m comma n order pairs you have to choose. So n can take only odd numbers and the set is 1 to 50. So how many odd numbers are there to place in here? 25 into, you can fill any m value, so that is 50. So 50 into 25 means 25 5 is 125, 1250. So this is P. Okay, so we got P. Now they are asking for Q. Q means the number of elements m comma n is such that m plus n is a square of a prime number. So m plus n is a square of a prime number. So first see what are the possible values of this, right? So it can be, so prime number starts from 2, so it can be 2 square 4, it can be 3 square 9, it can be another prime number is 5 square 25. Next another prime number after 5 is 7, it can be 49. After 7 the prime number is 11, so which is 121. But here m and n can take the maximum values of 50, so it cannot take 121, right? So here m plus n can be 4, m plus n can be 9, m plus n can be 25, m plus n can be 49. So now you need to calculate how many m and n are possible for this kind of equations. So it's clearly m and n belongs to this natural numbers only, so that means total number of positive integral solutions we can form, because this number does not exceed 50, so even m and n values does not exceed 50, right? So the number of positive integral solution formula is n minus 1 c r minus 1, right? Here n is 4, 4 minus 1 means 3, r is 2, 2 minus 1 is 1. So here you are getting 3c1, here 8c1, here 24c1, here 48c1. So how much? 48 plus 24, 62, 48 plus 24, 72, plus 8, 80, plus 3, 83. So Q is 83. So we got Q is 83. Now we need to calculate P plus Q. So how much is P plus Q? 1250 plus 83, 3 and 13, 1333. So the answer must be 1333. Done. So it is also an easy question. Next, question number 11. So let's go for the question number 11. So let S equals to 1 to 9. Let X be the 9-digit numbers formed using the digits of the set S such that only one digit is repeated. So it is also easy question. So S means, so the first part is let X be the 9-digit numbers formed using the digits of the set only one digit is repeated. It is repeated exactly twice. Let y be the number of 9-digit numbers formed using digits of the set S such that only 2 digits are repeated and each of these is repeated exactly twice. Okay, clear. The question is very clear. Then they are asking for relation between x and y. Okay, so what we can do? So to find x, 9-digit number should be formed. Exactly one digit should be repeated twice, right? So out of these 9, I will select any one of them to be repeated. Okay, suppose I have selected any one of them and it is taken twice. Now how many digits are required now? 9-digit numbers now. So we required 7 more digits because already 2 are selected. So 7, how can we select? So out of this 9 we have selected 1, remaining 8 are there. So out of those 8 I can select any 7. Now we are having 9 digits, out of which 7 are distinct, 2 are repeated exactly twice. So in how many ways they can be arranged? 9 factorial by 2 factorial. This is x. Again y. Now y be the 9-digit number formed using the digits of the set S such that only 2 digits are repeated. 2 digits should be repeated. So out of 9 I will select any 2, right? Now those 2 will be repeated. That means suppose I have taken 2 and 3, so 2 2s and 3 3, it will come like this, right? So we are already having 4 digits. Now we needed 5 more digits. So how can we select them? Out of 9 we have selected 2, right? So that means we are left out with 7. Out of this 7 we need to select any 5. So now we are having 9 digits, out of which 2 are repeated once and 2 are repeated once. So that means in how many ways they can be arranged? 9 factorial by 2 factorial into 2 factorial. Now to get the relation between x and y, so just take the ratio. So x by y equals to 9 factorial by 2 factorial cancels out. So 9c1 means 9, 8c2, 8c7 means 8c1 only, 8, 9c2 means 9 into 8 by 2 into 7c5 means 7c5 or 7c2 we can write 7 into 6 by 2 into 1 by 2. Okay, 9 8s cancels out. 2 it will cancel out 3, so you'll be getting 4 by 21. So x by y equals to 4 by 21, 21x equals to 4y. That should be our answer. So where is the option? Yeah, so that's all the questions of session 1 from PNC. So by analyzing all these 11 questions, what we can analyze is, so definitely one question is going to come from PNC. Definitely one question is going to be there. And don't ever skip the PNC question, because PNC question is quite simple. You can see all these questions, most of the questions were simple and some questions were kind of lengthy, but we can solve the question, right? So don't ever skip the question without reading the question. Just try the PNC question. If you are getting the idea, just solve it. Otherwise you can skip it. Okay, right? So keep that in your mind, and all the best.